Okay, today we are going to talk about the definition of the differential equation. Just for your information, because some of you might not know what is the differential equation. So, usually when we are talking about differential equation, in chemical engineering, it is coming from the mathematical model that we derive from the process that we are interested in. It's just up to you, like if you derive from the reactor or the heat exchanger or whatever. But the main thing of differential equation, you have to have the sign differential relativity. In general, they just do the differential between the dependent variable and independent variable. The one which is always on the top is the dependent variable, and the one down there is the independent variable. Okay. So this is the example. It's the falling of the apple from apple tree. So you know, when you're thinking about the mathematical model, then you would end up with this equation. And then you can find the height that the apple falling down from the apple tree. With the time, then you would know how long does it take for the one apple to fall down from the apple tree, something like that. That is one example that you guys know from physics class. And the second one is the general differential equation, another term of the differential equation. Like I said, the way that you get the equation is depends on the situation that you're looking for. So if you compare with these two equations, you would see the dependent and independent variable. It's always happened like this. Okay? The first equation, what is the dependent variable? Dependent variable, the first equation. H, and the independent variable is T. The second equation, what is the dependent variable? Y, and the independent variable is X. So, if differential equation, you've got to know which one is the dependent variable and which one is independent variable. You've got to be able to distinguish between these two parameters, then you will know like what you want and then how to solve it. Okay. So from the number of dependent and independent variable, we can classify the differential equation into two main types. The first one we call ordinary differential equation, or ODE. This type of differential equation involves only ordinary derivative, which is the letter D. Okay? Put it in the simple words, you have only one dependent variable and one independent variable. That you call ODE, ordinary differential equation. And the second type we call partial differential equation, or PDE. P is from partial. In this case, we have more than one independent variable. The simplest thing that can make you distinguish between these two types of differential equation is the sign that you use. For ordinary, you use D, but for partial differential equation, you use the curve. For partial differential equation, the one that I give you an example, you will see we have only one dependent variable and two independent variable, which is x and y. Okay, so that is the difference between the ordinary differential equation and partial differential equation. These are kind of examples. When you see this equation, can you tell me is it the ODE or PDE? Just simple question. Now what I want you to know from this class is, can you tell the difference between the ODE and PDE? The first one is the ODE. The second one is still ODE. The third one is PDE. The fourth one is PDE. Now you can distinguish between ODE and PDE. Like I said, it's easy. Don't try to feel that this class is very difficult. Forget about the word difficult. Forget about it. You should know what is difficult means. You should know how to spell difficult. You should be able to spell easy. And you know only the meaning of easy. Then this class will be easy for you. Okay? Hey, someone laugh. That means you understand what I'm trying to say. Okay. The first equation, you have one dependent variable and one independent variable. Can you tell me what is the dependent variable for the first equation? The first equation. Why? What is the independent variable? X. For the second equation, what is the dependent variable? Y. What is the independent variable? T. The third one, what is the dependent variable? B. And what are the independent variable? S and T. Okay, and the fourth one is the very popular equation we call Laplace equation. Very important in engineering. And whenever you go to transform phenomena class, you always see this equation. So, what is the dependent variable for the fourth equation? V. And what are the independent variables? X, Y, Z. X, Y, and Z. So, generally, if you think about it, it's just the coordinator. The X axis and the Y axis and the Z axis, right? Yeah. And then the two words that I want you to learn is order and degree. Order of the differential equation means the order of the highest order derivative in the equation. For example, the first equation, you will see what is the highest order in this equation. To the second order. So you can say this is the ODE, ordinary differential equation with second order. Something like that. The word degree it means the power of each term. We're looking at the highest power in each term. For example, this one, the first equation, the term of derivative, the second derivative, the power of it is 1. The second term, the power of derivative is 1. So, this equation is the ordinary differential equation with the order of 2 and the degree of 1. The second equation. I did something wrong here. Sorry. This one is going to be y. The second equation. What would be the order of the differential equation? The highest derivative in the equation is third. The third order. Okay? And what is the degree of the second one? Each term has power of 1. So this equation is the ordinary differential equation with the third order and with the degree 1. You can say order of 3 and degree 1. The third equation, partial differential equation with the order of 1 and degree 1. The fourth equation is the partial differential equation with order of 2 and degree 1. Now you understand the meaning of order and degree. Next, we can also classify the differential equation when we look at the character of the equation itself into two terms again. The first one is linear differential equation, and the second one is we call non-linear differential equation. This equation, the one that I make it so big because I just really want you to, know what would be the general form of the linear differential equation. Linear differential equation always in this form. Any equation, any differential equation which is not follow this form, we call it non-linear differential equation. Now, we got to look at it closely, then we would know how to distinguish it. If you look at this is the differential equation order what? Order n, okay? And if you look at each term of the differential, you would see they have the power of 1, or we say degree 1. So if you want to classify it to be the linear differential equation, each term in that equation got to have degree 1. Now, the second thing that you got to concern when you consider this equation to be linear differential equation, you never ever see any product of differential equation and differential term and differential term. You see it individually, you never see the product of them. Right? You never see dy by dx times the second order of y by x. You never see any term like this. If you have any term like this, it's non-linear differential equation. Okay. First of all, you got to see each term has degree of 1. And you never have the product of dependent variable and the differential of it, or even the differential of it times the differential of it. Understand? And another thing that A0, A1 until AN got to be constant or function of independent variable, in this case, function of x. And this y got to be y, shouldn't be any function of y. It's got to be dependent variable, cannot be y times y to the power 2, cannot be cos y, cannot be sin y, cannot be exponential of y. It's got to be y. Any equation that don't have whatever is the same cases, we consider it to be a linear differential equation. An equation that have either one of whatever 4 things that I just said, we consider it to be non-linear differential equation. Understand? Too long or